In this problem, we have a much simpler circuit. We have a battery of 6 volts supplying current to our circuit, and in the circuit we only have 2 resistors that are in series. And we need to find the voltage across R2. So actually this is the quantity we're looking for, the voltage across R2. But we might as well go ahead and fill out this entire chart so that we have practice doing that. The resistance for resistor 1 is 33 ohms. The resistance for resistor 2 is 10 ohms. The first thing we're going to do is get the total resistance of this circuit. When we have resistors in series, that resistance adds together. So R total is just R1 plus R2. So that's just going to be 33 ohms plus 10 ohms, and that's going to equal 43 ohms. So the total resistance in this circuit is 43 ohms. This circuit is being supplied with a potential of 6 volts. So we can use Ohm's law in order to get the total current in the circuit. If V is equal to IR, then I total is equal to V total over R total. So V total was 6 volts, and we divide it by R total, which is 43 ohms, and that gives us a total current in our circuit of 0.14 amperes. So total current is 0.14 amperes. And when we have resistors in series, the current is the same through all of my resistors. So the current through each of my resistors is also 0.14 amperes, 0.14 amperes. To get the potential across either one of my resistors, I just use Ohm's law again for each individual resistor. So the potential across resistor 1 is the total current times R1. So that's going to be 0.14 amperes times the resistance of resistor 1, which was 33 ohms, and that gives us a potential across it of 4.62 volts. 4.62 volts. To get the potential across the second resistor, we use Ohm's law again. The potential across resistor 2 is equal to the total current times the resistance of resistor 2. And so that's 0.14 amperes times resistor 2 is 10 ohms, and that gives us a total potential of 1.4 volts. Okay, so over here I'll put 1.4 volts. Now, with our resistors in series, the sum of the potential across each resistor should add up together in order to give us the total potential. My battery was supplying 6 volts. If I add these together, I'm going to get 6.02 volts. Okay, that just was because of the way that I chose to round in this problem. But we still see that the sum of the potential across each one of my individual resistors gives me the total resistance, or gives me the total voltage in this circuit, as we should have when we have a circuit in series. In your pre-lab, all you're going to do is a similar problem to this, except you have to find the voltage or the potential across resistor 2. So we filled out this whole table, but for that pre-lab problem, you're only going to need to get this quantity right here, the potential across resistor 2.